morning.
Morning. All right, so today we're going to revisit this idea of constant, but we're going to apply it to classes that we're going to design. And then what we're going to do is we are going to dive deeper into this idea of object-oriented programming and being able to dictate how items interact with each other. Make sure, okay. But first, the faculty got an email from the provost yesterday, and my reaction is one I'm sure that many of you will appreciate. As such, the provost's office has accepted the recommendation that we move to replace Sakai beginning spring of 2021. So that was my reaction when I saw that this morning. So I think many of you feel the same way. So it might be moving to Canvas, which I use at the University of South Florida, and is a tremendous tool and I like significantly better. Okay, so the first thing I'd like to show you is a review of how to make files while building classes. So in the code that I showed you on Wednesday, what we did is we built a point class, then we had a line class, and then we put them together in a program, and then we put together all of the objects. So over here on the left, I have an example of this class intro. And the first thing that we have is we have this point.o, and we create with the point.cpp and point.h. So we're making these together in order to be able to test all of the methods and the class construction. Then we have the same thing with line.o, but you also notice that in line.o we have line.h, and in line.h we have point.h included. So we are able to test to make sure that how we're interacting within these class aggregation is working properly. Then we have class intro. So when we include line.h in class intro.h, we are also including point.h because it's been included by default. So anything with the libraries that you have in there, for example, if you have point.o and you have iostream in there, iostream will automatically be included in class intro.cpp as well. So from there, we have the class intro objects. So this is what I've been preparing you for all semester. This whole thing of putting the objects together, and earlier we only would have one object, but we still wanted to define it. The reason why is because as your programs get bigger and bigger, you can put together a larger range of objects to be able to compile everything together. And we can see that we have 3 objects here in the definition. And then in the actual executable itself, we use this line where we take all of those objects and we combine them from objects into the one executable, which allows us to be able to run the program. Does everybody see how this works? All right, does anybody have any questions? Check the chat as well. All right, so what we've seen so far in C++ with this idea of constants is that we could use it to define a variable that is constant throughout the program. And this was better than just using a normal variable in C, because C made multiple copies, which led to compiler errors, which were difficult to troubleshoot. So in C, what we did is we used a pound define directive to get around that. And that told the compiler that anywhere you see this keyword, replace it with this particular variable, with this particular set of characters. Then we introduced this idea of constants, so we could actually define the type. We have more control over the type in C++. So for example, here I have const float pi. And this is good because if we only have a 32-bit architecture, we can't represent doubles unless we use 2 values, which could potentially slow down the performance of the computer because we have to load one object and then load another object and combine them together. And so we've seen this example of constness, but we can also define const versions of classes that we describe, right? So we can say that a specific object is const after we construct it. So this runs into some potential problems. The major problem is that some methods that you have are perfectly fine. For example, for point, maybe we have a method getX. And getX will just return the value of X, and that's no big deal in a const object. But I also might have a method setX that allows me to change the private member. So I have to have some sort of way when I define a class object to be const of which methods I can use and which methods I can't. Does that make sense? So we need to be able to differentiate between those. All right. So what we are going to do is we are going to say how it, that I literally just said everything on that slide. Okay, so what we're going to do is we're going to use a const keyword when describing our classes, our class methods. And the good thing about this, an important reason why you should learn this now as a fundamental programmer, is that the more that you use const, the better and fewer compiler errors that you're going to get later on. So you're going to have all these different objects interacting, and sometimes you're going to want to make sure that specific object can't be changed. But the person who's using your class maybe doesn't fully understand what it is that you're trying to do, or maybe hasn't read all the documentation. So what's going to happen is we have to figure out a way in which we can dictate to the programmer, if they try to use a method that tries to change a const version of a class, how is it that we can tell them that it's not going to work? And if you use strong fundamentals of using const, this will save you potentially hours of troubleshooting later on. So this is a good habit to build. So use const correctly and use it from the start. And we are going to use this keyword for member functions that do not change the data members of your classes, and use const for object parameters whenever possible. Meaning that if you're using an object parameter and it's not going to be changed, use const to make sure that no one's trying to use changeable objects. So for example, if I define a variable in main that's not const, and I don't want it changed when I pass to an object, then you can write class methods that will define them as const for you. And what will happen is that will preserve the integrity of that variable. Hey, does anybody have any questions about this before I start digging into some code? Okay, so some rules of engagement with const. So I want to go through step by step on these 6 and make sure that we understand what we're doing before we really dig in. So rule 1, const member functions may be invoked for const and non-const objects. So what this means is if I have a point class and that point class is getX, it has that member, and we define it as const, it can be defined by any point, it can be called by any point object regardless of whether it's const or not. So that's rule 1. Rule 2, non-const members can only be invoked by non-const object. So setX in a point class. We would not define that as const, and therefore, if we define a point object as const, and then try to call setX, excuse me, it will throw a compiler error. It will say, wait, you default said that this object may not be modified, so therefore, we are going to make sure and hold you to that. Now, the reason why this is important is because when you're trying to use a const object and you haven't properly defined it as something that can be as const, what ends up happening is that people might end up using your objects and changing things that shouldn't be changed. And as a result, it will cause serious problems. And you'll try to figure out, why is this code going wrong? When really, you just want to make sure that your programmer doesn't use it. So if a const member function is invoked on the const object, it's a compiler error. Non-const objects may be used for const and non-const parameters. So you can pass non-const objects to a const method. You can do that. The thing that you cannot do is when you call const, it cannot change an object's member values. So for point, we have two floats, x and y, right? If I write a method, I'll just call it func, and we pass float z, right? And float z, for some weird reason, just says z is equal to x plus y. There's no actual reason why we want to do that. But if I call it by reference, it's perfectly okay to change the value of z and then return it. But if I say x is equal to z in a const method, then it's not going to compile. We want to make sure that we can protect these values. So const objects may only be used for const parameters, and then const methods cannot invoke non-const methods. So we've discussed this. All right, does anybody have any questions about this before I continue? Okay, I'm going to skip on here to the point class. So here, I have now defined my point.h, but now what I'm doing is I'm going through and I'm adding the const keyword. So I still have type def float coordinate. I still have class point. Neither constructor has const because, and that's hopefully intuitive, but the reason why we don't have const and a constructor is because we actually have to make the objects different. So by definition, a const, we cannot make constructors const. These two methods, coordinate get x and coordinate get y, return the values and do not change them. Therefore, a const version of a point may invoke these. So therefore, what we do, there we go. What we do is we would say the return type, then we have the function name and the preconditions, and then in between the semicolon, we add the keyword const. Okay, does that make sense? So this allows us to say that a const version of a point, after it's constructed, may call get x and may call get y as well. Now set x, and I can show you, well, I'm going to show you the .cpp file so you can see how to put these in a class definition. But here, what this method is doing is it's going to update the value of x using coordinate in x. Therefore, it can modify the private members x or y, and therefore it cannot be a const method. Does that make sense? So I have these two definitions for set x and set y. Print point, let me zoom out just a little. Print point just prints out the values, and I call that as const. And then I'm going to ignore this line for now. I'm going to revisit this later in the lecture about this operator method. Now for point.cpp, I have the same thing here for the class definition. So I have the constructor, so to review, I have the class name, and then here I have point. This is the constructor here with the member initialization list. So here we have the default constructor. Then we have the overloaded constructor, same thing, class name, constructor, and then the member initialization list. Neither have const. Now with the coordinate, we have get x and get y, and we put the keyword const there. Does everybody see that? So that allows us to be able to say that we have a keyword const. This can be invoked by a const point. Now the crucial thing is that if you have one defined in the .h file as const, it must be defined in the .cpp file as const as well. And this will result in a compiler error. So let me show you an example of this. I'm going to take out const from getX. I'm going to upload it. Make sure I'm in the right place. So make advanced classes. And so we get a compiler error. And the compiler error states that prototype for coordinate point getX does not match any class in point. And so you get frustrated, like, what are you talking about? I have this. And the keyword here is that it will try to throw a candidate. So here it says candidate is coordinate point getX const. And you'll see that they don't match and go, oh, I have one of them defined as const and the other one is not const. So then what I would do is I would get rid of this HP support assistant that I accidentally opened. And then what I would do is I would say, oh yeah, that should be const, that's a const method. Okay, so does everybody see that? All right, so yeah, yes. We want to be able to, if I want to say that a point object, after it's constructed, it cannot be changed. But if I want to be able to access its private members, excuse me, then I would say that a const version of point may call get X or get Y. Does that address your question? Okay. Any other questions? Let me check the chat as well. And we don't have anything in the chat at the moment. Okay, so let's go over this particular piece of code. And then what I'd like is for somebody to tell me what they think the issue with this code here is. So I have a class day of year, and I call get day const. And then I have mday is greater than one set method m month one return m day. So this throws a compiler error. What do you suspect the problem is? Anybody have a guess here? Yes. Oh, no. No, assume that these are, let me assume that all of the methods are valid. So what is that? Okay, so m month is changed here in a const method. That is absolutely right. That is the issue here. So we are saying if the day is less than 1, then we're going to set the month to 1, right? And since we're changing m month here in a const method, it's going to not like that. Okay, so here's another one. I want you all to walk through the same thing. Same assumption. Sorry, I don't want to mislead. All the members of the class are defined in here appropriately. So we have a function here. So what do you think? What is it that I'm trying to do here that might cause a problem? Yes. Yeah. Mm-hmm. So I'm calling a parameter in this function here. So this is a function void Bob, right? And I have a const, and I'm calling it by reference. And here I'm trying to call a set method on a const object. So a properly written day of year method set would not have const after it because I would want to be able to change the members. So let me combine some concepts here. If I'm having a const, and I also have call by reference, why is this a good programming practice? And I throw this out there because the two things I've told you are, we do this call by reference so we can modify the value in the function, right? But then I also say we do const because I don't want to modify it, right? So I seemingly have given you a paradox, but there's something through that makes this a good coding practice that I've taught you specifically about what we are doing when we call by reference. Does anybody have any idea as to what we're accomplishing here? Yes. 100% absolutely right. So what we are doing here is that we are only passing a pointer. Call by reference also allows us to simplify the programming. We don't need to do any of that dereferencing complex stuff that we did in C, right? So this makes the programming easier. We do not need to make an entire copy of the object. But now I'm adding const to ensure that I don't want to change it in this particular method. So we have we've reduced the amount of memory required to complete the operation. We've reduced the complexity of the coding that's needed in order to write the code. And we've ensured the integrity of the data. Does that make sense to everybody? So that's why this is a good coding practice right here. Okay, so now let's go through. And I have this, I want to do one last thing. So this would be more of a type of a problem that you would see on an exam. I would give you a class, and I would ask you, and I would list all the methods as choices, and you would have to select which ones you would want to modify to be const. Okay, so let me go through. I'm going to ask you which methods we're going to be doing here. So on the left, we have .h file. On the right, we have a .cpp file. So we see the entire operation. So first, we have the constructor. Yes or no? Should we make this a const method? A lot of shaking heads. No, absolutely right. What about standard string get name? So here we're just returning m name. Is this something that we should define as const? Okay, so I have some contradictions. I see some yeses and I see some nos. So for the nos, so Henry, I'm going to pick on you because you're closer here. So what is your reason for believing that it should be that's no? Okay, so it's about whether or not we're changing the name. So Jacob, since you're closer here and you said yes, I'm going to pick on you. So why do you believe that it's yes, we should make this a constant? Okay, so Jacob has answered your question about this. So it should be a const method. So you are right. And the reason why is because all we're doing is returning a copy of the name number. We're not making a modification. So this one, so we're going to say no, we're going to say yes. What about int get age? Okay, so a lot more confidence. We're seeing a lot of yes here. Okay, so we have this function void happy birthday. So here's person happy birthday. I do standard cout happy birthday m name, and then I do ++ m age. Should this be const or not? Okay, a lot of heads shaking no. That's absolutely right. And the reason why it's no is because of that m age. So very good. Yes, question. Yes.
If there's a function that modifies, say, happy birthday,
yeah,
you don't have it labeled as const, but you try to call that function on a const object, will it change the number variable?
All right, so the question is, if I define it not as const, I say const person, right? And you call this method, what will happen? The answer is it will throw a compiler.
The concept is it can never change the variable except for the
Absolutely right. So for those of you in the chat, the follow-up comment is can const objects never change anything after the constructor? The answer to that question is yes. Any other questions? Okay, so then we see that your choices were absolutely right. So good job. So now what we want to do is we want to combine some concepts here and talk about this idea of objects simulating interactions. So up to this point in C, when you had a plus or a minus or a division or some sort of operator, you would know if for int, I have x equals 4, y equals 2, y equals x plus 7, right? So now we would know that y is equal to 4 plus 7, so that's equal to 11. And so you may have heard me use the term primitive types in passing. The reason why we call these primitive types is because in things like integers, characters, floats, and doubles, we have these operations defined already. That tells us what to do. We do some sort of operation, it's defined in the hardware, and we let the work go for us. However, in C++, we can use these operators on a class that we have defined to do the work for us. If we define this and then we later say plus, we can say how two different objects would work together, right? I can define this, and you've already encountered an example of this. So in last week's lab, when you had to do the reversal, right? So you're doing the palindrome, and I gave you that example of a string, and in that code I said you could call reverse string, and then you do the character plus reverse. Does everybody remember that? So that is an example of what we're going to call an overloaded operator. In C++, the string library says I can call concatenate using a plus sign. I'm just going to do all this work and abstract the complexity away from the user. So in C, you learn the fundamental procedural approach to do this. And now in C++, you can learn the abstracted way to do this. So it's a little simpler, but because you learned it in C first, you understand what's going on in the machine and you can write more efficient code. So if I create a class money, it's not going to have this by default, right? It's not going to have, if I say M1 plus M2, it's not going to just do it magically for me. I need to be able to write my own versions of this. So here's the way we're going to do this. I'm going to walk through it step by step, and I'm going to show you some code examples on how to actually implement this in several different types of operators. So in everything that we've learned about classes includes this so far, right? So what's going to happen is we are going to say return type, a class name, and now I'm going to point out this operator thing that I've scooted right on past. The operator is a keyword that is required that we need to use in order to indicate what the operation we want to do is. So for example, if I wanted to do plus, I would say operator plus. If I wanted to do greater than, it would be operator greater than. If I want to do operator equal to, equals equals. You can use these primitive types and primitive operations, excuse me, to be able to build in your classes to compare things. So if you write classes for money, you can compare inside, you can say, well, if it's equals equals, the integers for dollars and for cents must be equal as well. So if they're both equal, return true. And that allows you to be able to define these types of operations. So furthermore, this is where another benefit of const comes into play. When you call an operator and you pass an object by const to that operator. So for example, if I am saying that this is a money class and I pass a money object as const to an operator, I can access the private members inside that method. I don't need a get X method, I don't need a get Y method, I can access those. So now another key thing I want to discuss before I move on to the next slide is the reason why I have const here. So this may not seem intuitive why I want to do this. A equals B plus C, well, I'm changing A, right? So here's the way this operator would actually work. So for a operator greater than, right? So operator greater than, we're going to see that it returns a bool. And if I say A greater than B, the way the computer is actually performing this operation is that A is the calling object. It receives B as an input, and then it returns the Boolean, right? So to perform this operation, I don't change anything in A. Does that make sense? So now let's go to addition, and I want to walk you through that again. So if I say A equals B plus C. So why should I say this is const? Because the object that is actually calling this is B. And the one that's being passed to it is C. What's returned is A. So when I do A equals B plus C, B is never changed. So therefore, a const object may be called here. Because if it's const, if I'm never changing B, I can still add it, right? And likewise, I'm passing it C by const, and C is never changed as well. We are accessing the members of the classes, performing an addition that we dictate to it, and then return a new object. That is the object that is changed. Does that make sense? So therefore, we are not changing this again. And I'm happy to walk through that explanation again, because sometimes that can be a little confusing. So if anybody is confused about it or would like me to do that again at some point in this lecture, I'd be happy to do so. Yes? Okay, so for the, generally no. But you can do it if we have two different objects, but we are eventually, what we're going to learn later in this lecture is a keyword called friend. And so the answer is to be answered later. And when I get to that, I'll follow back up with you to see if it's clear. All right, any other questions? Okay, so I have a method complex. And I have complex.h. And in this, I have two integers that are private members, int real and int imaginary. So basically, I'm doing a complex value. And then I have a constructor, And what I would like to do is I'd like to quickly introduce what's going on here. So here I have int r is equal to 0, int I is equal to 0. Does anybody have a theory as to what I'm doing there? This is a neat little constructor trick. Save you some work. Any theories? No wrong answers. Yeah, that's right. Forgive me. What's your name? Gabriel. Sorry. So Gabriel, please give me your guess, and then Jake, I'll ask yours as well. Sorry, Jacob. He said the exact right answer. Yes, that's exactly right. This is a default for if I call the default constructor. So if I call the default constructor, meaning I don't pass anything to it, what I can say is we'll set r is equal to 0 and I is equal to 0. So instead of having to write two constructors, I can call this, and then r and I will be defined in the member initialization list in complex.cpp. So let me show you that. And we see here that I don't need to put that in the .cpp file. It will make it by default 0. But if I call the constructor and make them different values, it will overwrite them. So what C++ is allowing you to do is it's trying to say that I can write one constructor where these values I know what they're going to be by default, whereas here I can then say, well, I can call the same constructor for ones where I actually have values I want to define. Right, does anybody have any questions on that before I go into the actual operators? Okay, so we have set real and set imaginary. You can see that they are not const because I want to change the members. And then I have int get real and get imaginary, which are const because I'm just returning the values. And so now what I have here is complex operator plus, and then you'll see that I have const complex with a call by reference, and RHS is just my little notation for right-hand side. So if I'm having A is less than B, I know which one is the right-hand side and which one is the actual object. And because I'm not changing the object at all, I have defined this one as const. And I've done this for addition, subtraction, equals, comparison, greater than, and less than. So again, I will revisit this friend operator in a little bit, but to get to the first part of your question from earlier, and forgive me, what's your name? Okay, so Stephen, this is where we have multiple objects, and I'm going to explain why we have to say it's a friend and not just an actual member of the class. So in complex test.cpp, in complex.cpp, let's go down here to the operator. So here I'm returning a result of an addition. So this would be maybe A equals B plus C. And we see that I created an object complex solution, right? So sol would be A. This object is B, and then RHS is C. Does everybody see that? So now what's going to happen is I say sol real is equal to real plus RHS dot real. So this is going back to what you were doing in instruction. The reason why I am able to say dot real there is because I have an operator that is a member of the class, and I passed it as const, and it's the same type. Everybody see that? So as a follow-up, you have to do friend when you want to do more than one, or you're passing a variable to the method that is not of that type. That's one of the rules. So here I'm just doing real would get this specific object, and then I return sol. So that allows me to do this. And then here I have minus. I'm doing the same thing except just real minus RHS.real and imaginary minus RHS.imaginary. And then I'm returning this. So I'm defining how complex objects should be added and subtracted. For the operator greater than, I say if real is less than RHS real, return true. Then if they're equal, then I compare imaginary is less than RHS imaginary. And if either of those doesn't pass, then it's false. That's just an example. And then I do the same thing for greater than. So does that make sense? Yes? Okay, so okay, it is not changing what the inputs are. So let me go back up to the addition because this is the best example, okay? So here, in addition, what this is doing is it's let's just say A equals B plus C. Simple example, these are three complex objects. The one that is calling the function is B. Does that make sense so far? This one, right-hand side, is C. In this method, I don't change B at all. So therefore, if I have a const version of a complex variable, and I want to be able to add it to something to get a new one for some reason, I can define this and that a const version of the complex object should be able to call it. Does that make sense? I sense skepticism, so if you have a follow-up, please feel free to ask. Okay. Any other questions? Let me check the chat. Okay, so when I go through the actual code, maybe this will help make sense of everything. Okay, so overloading operating. So I showed you all these, I showed you all these, showed you all those. Okay, so in complex test, I have two complex objects, right? And here I go through complex C1. Okay, so again, ignore that for a moment. If it's less than, C1 is less than C2, it'll print this out. If C1 is greater than C2, it'll print this out. If they're equal, it'll print this out. Here I'll just have nothing. This complex C3 and C4 have overloaded plus operators. And then I'm going to print those out so we can ignore this. But let's say that I make this one, I say complex, const, complex C2. And in fact, let me make const C1 so that way it's a little clearer. So now what I'm going to do is I'm going to upload the code and I'm going to compile running make complex test. Don't think I have the error in there. It's not. Okay. So now I'm going to run complex test. And now, okay, so ignore this for a moment. So I'm going to say 4 and 7, and that allows me to read into an object. So what this allows me to do is I'm able to perform an addition here because what I'm doing is I'm saying C3 is equal to C1 plus C2. If I say C1 is const, and I don't want it to change, I can still want to be able to perform this operation because C1 plus C2 doesn't change C1 or C2. Does that make sense? So therefore, what's going on is that C1 is actually the calling object here. C1's going to say, all right, what we're going to do is we're going to add, I'm going to create a new complex object, C3, and then I'm going to take these two and I'm going to add them together and store the results in C3, and I'm returning a completely new object. So what I can do is I can say that C1 is const. I never want it to be changed for some reason, whatever you decide in your program, but I can still use it to be able to perform other tasks. So does that clarify? Yes. So if I were to say, here, I'll actually produce an error here. So let's say up here I go C1, what was the method I called it? I called it get set imaginary, right? So let's just call set imaginary. I'll say -1. So what's going to happen here is we're going to get a compiler error because I have said I don't want it changed, and then I went and tried to change it. So now I can differentiate which ones I want to change. Now, if I want C2 to be able to be changed, so you see how C2 is not const? If I change this to C2.imaginary, this code is going to run just fine because I have dictated that C2 is a complex object that should be allowed to be changed. Do that? Awesome. All right, so there's one last big thing I would like to go over before the end of lecture. I'm going to start Friday's lecture with a 5-minute description of friend operators. I apologize. I'll get to your question in detail. Today is Wednesday. Okay. It's been a long week. What I would like to do is I'd like to show you what happens. First, let's not show you data structures code. When I forget to do an operator. So what I'm going to do is I'm going to comment these out, right? So now they're gone. In fact, in .cpp, I'm going to comment them out as well. Okay, so operator method declaration, any definitions.cpp files, and try to do the results. Okay, so what we're going to see is we start getting a lot of compiler errors, right? And here it's going to say no match for operator. And it's going to say if C1 is less than C2. Does everybody see that? And likewise, it's trying to access all of these different things. And then let's say I have some in there. So let's say I have what set real, set imaginary, get real, imaginary. So let's say I have less than, and I comment this out. So I have some operators. Or you must define that operator, otherwise you get large compiler error. What am I doing that to? Oh, okay. This will be a thing that I'll bring about in more detail on Friday. But I'm going to come out these two out. There we go. We got a giant compiler error. Thing looks nasty, huh? Remember I told you I would run a compiler error that would look huge, and it just keeps going and 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 going. So remember what I told you at the beginning of C++, how sometimes if you're using C++, it's much more efficient, but if you don't know precisely what you're doing, you don't know that underlying problem, that Yarn H. Joshua said it can potentially blow your leg off. So this is your first example of what appears to be a really nasty compiler error. And what I'm going to do is I'm going to uncomment one of those so I don't get it so bad. Okay. Actually, I'll do the one that's less. so we don't get it so bad. And this will be the last thing. This is what we'll conclude lecture on. So my first recommendation I run into something like this is I press enter several times, and then it does this. And then first thing you should do, take a deep breath. These errors are usually nowhere near as bad as they look. So here you scroll up all the way to the top, and you look at the very first thing. So they have this differentiated in blue and red. So here it just says no operator for what we're going to define on Friday as reading in. So this is its equivalent of scanf. And then the rest of this is in light blue. Notice how it says candidates are. And so what it's doing is it's going through the entire C++ library and trying to see different versions of different operators. So here we have void pointer, remember those? Stream buffers. It's going to try another one, basic iStreams with an unsigned character. The C++ library has all kinds of different variables. And what that's trying to do is say, hey, look, this is every possible thing. If you scroll up to the first one and go, oh, hey, maybe I should check in my friend operator. And then you'd realize, oh, wait, I don't have one. So you write one line of code and all of those errors disappear. And we see that it now works. So we're going to go into more detail about that in the first 15 minutes on Friday, and then you'll be able to do a lab assignment, create your own class. On that note, it is 10:02, so we're all dismissed. Hey, Brenna.